December 17, 1942, the North Atlantic. The USS Cadence plowed through 30-foot swells as freezing spray coated its deck in a dangerous sheen of ice. Below decks, Chief Petty Officer Marcus Winters stared at the hairline fracture running along the hull's welded seam, knowing that if it spread even 6 more inches, the entire Liberty ship would crack in half like dozens before it. Behind him, the captain and 3 engineers argued about whether they should attempt to turn back or continue on their vital mission to deliver munitions to Allied forces in England. What none of them realized was that the conventional welding techniques they trusted would fail catastrophically in these frigid waters, and that the solution to this deadly problem would come from a man the Navy had relegated to cooking meals rather than practicing his true expertise. Before we dive into this story, drop a quick hi in the comments and tell me where you're watching from. It really helps support the channel. This is the untold story of how one overlooked black welder would discover a revolutionary technique that saved countless Allied ships and lives during World War II, fundamentally challenging the prejudices of his time while transforming naval engineering for decades to come. The year was 1941, and Ellis Johnson stepped off the Greyhound bus in Baltimore, Maryland, his worn leather suitcase containing everything he owned. At 27 years old, Johnson stood at an imposing 6 feet 3 inches, his muscular frame honed from years of physical labor. His dark eyes scanned the sprawling shipyard ahead. Bethlehem Fairfield, one of America's largest wartime shipbuilding operations. Johnson had come from rural Georgia with 15 years of welding experience, having learned the trade from his father, who had worked maintenance at a textile mill. "You sure you want to apply here?" the bus driver asked as Johnson retrieved his case. "A lot of trouble lately between the colored workers and management." Johnson nodded without responding. He'd heard about the tensions, but he'd also heard the shipyard was desperate for skilled workers. With America's entry into the war looking increasingly inevitable, President Roosevelt had already announced his ambitious Liberty ship program, a plan to build cargo vessels at an unprecedented rate to replace those being sunk by German U-boats in the Battle of the Atlantic. The nation needed welders, and Johnson was among the best. The hiring office was a cramped, smoke-filled room with a line stretching out the door. Johnson took his place at the end, behind 20 white men. 3 hours later, he finally reached the front. "Name?" asked the balding man behind the desk, not looking up from his paperwork. "Ellis Johnson, sir." The man's eyes flicked up briefly. "Position?" "Welder, 15 years experience." A snort. "We got plenty of porters and mess attendants, don't need no more welders." Johnson stood firm. "Sir, I've been welding since I was 12 years old. Worked 6 years at Savannah Shipworks. I can lay down the cleanest bead you've ever seen." The man looked irritated. "Listen, we got quotas and—" "Test me." Johnson's voice remained respectful, but carried an unmistakable confidence. "Test me against any welder you got." Perhaps it was the shortage of skilled workers, or perhaps it was something in Johnson's steady gaze, but the hiring manager hesitated. "All right, follow Peterson here. He'll take you to the testing area, but don't get your hopes up." The testing area was a section of the yard where applicants demonstrated their skills. Johnson was handed a welding rod and mask and pointed toward a piece of steel plating. A small crowd of white workers gathered to watch, some snickering. Johnson ignored them, focusing entirely on the task at hand. Donning the mask, he struck an arc and began welding. His hands moved with a surgeon's precision, laying down a perfect bead along the seam. When he finished, even the skeptics fell silent. The weld was flawless, smooth, even, with perfect penetration. "Damn," muttered one of the observers. "Where'd you learn to weld like that, boy?" Before Johnson could answer, a man in a foreman's cap pushed through the crowd. "I've seen enough. Get him registered." He looked at Johnson. "Report tomorrow at 6 a.m. You'll be on Donovan's crew." That night, Johnson found lodging in a crowded boarding house in Baltimore's segregated black neighborhood. The landlady, Mrs. Talbot, a stern woman with kind eyes, showed him to a small room he would share with 2 other shipyard workers. "You just arrived?" asked one of his roommates, a stocky man introducing himself as Walter Dixon. "Got hired today," Johnson replied. "As what?" Dixon's eyebrow raised. "Welder." Dixon exchanged glances with the other roommate, a younger man named Raymond Carter. Well, I'll be damned. They must be desperate. I've been there 3 months, still just hauling scrap. What's your specialty? Johnson asked. Been riveting 7 years. Still got me carrying steel. Johnson nodded, understanding the situation. Despite the desperate need for skilled labor, black workers were routinely relegated to unskilled positions regardless of their experience. The fact that he'd been hired as a welder was unusual, though he would soon discover the limits of this apparent progress. The next morning, Johnson reported to the yard before dawn. He was assigned to one of the many Liberty ships under construction, the SS Robert Peary, named after the famous Arctic explorer. These vessels were being mass-produced using a revolutionary new technique, welding instead of riveting. Traditional shipbuilding had relied on riveting, where metal plates were joined by heating metal rivets red-hot, inserting them through aligned holes in the plates and hammering the ends flat. Welding, by contrast, used an electric arc to melt metal along a seam, creating a solid joint when cooled. Welding was faster, required fewer workers, used less material, and created lighter, stronger ships, critical advantages in wartime production. Johnson's foreman, Patrick Donovan, was a gruff Irish-American with a reputation for fairness. He assigned Johnson to work with a white welder named Frank Morris on the ship's hull. Johnson here is going to be working with you, Morris, Donovan said. He's got experience. Morris, a thin man with a permanent scowl, barely acknowledged Johnson. Just stay out of my way and follow instructions. For the next several days, Johnson found himself performing the most basic tasks, holding plates in position, grinding down rough spots, and cleaning up after Morris. Despite his demonstrated skills, he was treated as an assistant rather than an equal. Still, he observed everything, paying particular attention to the shipyard's standardized welding techniques. The Liberty ships were being built with a focus on speed rather than longevity. The U.S. Maritime Commission had ordered their construction using a modular approach. Different sections were prefabricated and then welded together on the assembly line. The entire process had been streamlined to the point that the average Liberty ship could be completed in just 42 days, with the record holder, the SS Robert E. Peary, famously assembled in just 4 days and 15 hours. But as Johnson watched the welders at work, he noticed something concerning. The standard technique being taught to the thousands of newly trained welders, many of them with just weeks of experience, involved creating continuous, straight-line welds along the hull plates. While this approach was fast and easy to teach to novices, Johnson recognized potential weaknesses in the method, particularly where different thicknesses of steel joined together. "You're doing it wrong," Johnson said quietly one afternoon as Morris completed a seam. Morris turned, anger flashing in his eyes. "What did you say?" "That joint, where the thicker plate meets the thinner one. The way you're welding it, it's going to create stress points." "I'm following the damn blueprint," Morris snapped. "This is how we've built hundreds of these ships." "Maybe so, but it's not right." Johnson pointed to the weld. "See how the heat affects the metal differently on each side. The thinner plate expands and contracts more than the thicker one. Over time, especially in cold water, that's going to create fractures." Morris threw down his welding rod. "Listen here. What's the problem?" Foreman Donovan approached, his expression wary. "This boy is telling me I don't know how to weld," Morris said. Donovan looked at Johnson. "Something you want to say?" Johnson hesitated, then decided to speak his mind. "Sir, I've been noticing a problem with the standard welding pattern on these junction points. The continuous straight-line method creates weak points where plates of different thicknesses meet. These ships are built to a specification approved by the Maritime Commission," Donovan replied. "I understand that, sir, but I think there's an issue with the spec itself. Back in Savannah, we used a different technique for joining dissimilar thicknesses, a staggered pattern that distributes the stress. We don't have time for fancy techniques. We need to get these ships built. It would actually take less time than fixing fractures later, and it could prevent catastrophic failures at sea." Donovan studied Johnson for a long moment. "Show me what you mean. On that scrap piece over there, not on the ship." Johnson nodded and moved to the scrap metal. Adjusting his welding mask, he demonstrated a technique that was radically different from the shipyard's standard approach. Instead of a continuous, straight bead, he created a pattern of overlapping, staggered welds, almost like a series of interlocking fingers. The technique allowed for more flexing and movement between the different plates while maintaining the joint's integrity. When he finished, Donovan examined the weld closely. "Where'd you learn this?" "Developed it myself, working on barges back in Georgia. They were constantly flexing as they moved through different water temperatures. This pattern allows for that movement without cracking." Donovan scratched his chin. "Interesting, but we follow the blueprints here. The engineers know what they're doing." Later that week, news reached the shipyard that alarmed everyone. A recently completed Liberty ship, the SS John P. Gaines, had broken completely in half during a storm in the North Pacific. It was the third such failure in 2 months. In the break room, the incident dominated conversation. "They're saying it just split right down the middle," one worker said. "Snapped like a twig." "Those U-boats are getting bolder," another suggested. "Wasn't a torpedo," Walter Dixon interjected. "Ship just broke apart. No attack." Johnson listened quietly, his concern growing. If Liberty ships were breaking apart without enemy action, the cause was likely structural failure, possibly related to the very welding issues he'd identified. That evening, Johnson approached Donovan after the shift ended. "Sir, about those ships breaking apart." Donovan glanced around, making sure no one was within earshot. "What about them?" "I think it might be related to what I was saying about the welding techniques, especially if these failures are happening in cold waters." Donovan looked troubled. "The brass is saying it's just bad luck. Few ships out of hundreds." "Sir, with respect, I think it's more than luck. Steel gets brittle in the cold. Combined with those stress points from the welding pattern, it's a disaster waiting to happen." "And you think your finger pattern would fix it?" "I believe it would help significantly. The interlocking pattern would distribute stress more evenly, prevent concentrated fracture points." Donovan was silent for a moment. "I'll tell you what. I can't change the official plans, but I've got a small section on the aft hold that needs finishing. Do it your way there. If it tests stronger, maybe I can bring it up the chain." Johnson nodded, grateful for the opportunity. "Thank you, sir." For the next 3 days, Johnson worked diligently on his section of the hull, applying his staggered welding pattern. When it came time for the inspection and stress testing, his section outperformed the standard welds by a significant margin. "I'll be damned," Donovan muttered, looking at the test results. "You might be onto something here." But bringing the innovation to the attention of management proved challenging. Despite Donovan's efforts, the shipyard's chief engineer dismissed the findings as anomalous and insisted they stick to the approved methods. Johnson's technique was relegated to a brief mention in a report that was filed away and forgotten. The dismissal wasn't surprising, but it was frustrating. Johnson continued his work, now respected by Donovan but still facing daily prejudice from many of his white colleagues. In the segregated shipyard, black workers ate in separate facilities, used separate bathrooms, and were passed over for promotions regardless of skill. As 1941 drew to a close, the Japanese attack on Pearl Harbor thrust America fully into the war. Overnight, the shipbuilding program went from important to absolutely vital. Liberty ships would form the backbone of America's maritime strategy, delivering crucial supplies to allies across dangerous waters. With the intensified production schedule came increased pressure and corners cut. Quality control became secondary to speed. Johnson watched as welders with minimal training were assigned to critical sections of the ships, while he, despite his proven expertise, remained limited in his role. One evening in early 1942, Johnson returned to the boarding house to find Dixon and Carter in an animated discussion with a newcomer, a sailor on shore leave named Marcus Winters. "These fractures are happening more and more," Winters was saying. "My last crossing, we had to weld repairs on the hull 3 separate times. If one of those cracks had gone unnoticed..." Johnson introduced himself and joined the conversation. "Were these fractures along the welded seams?" Winters, a stocky chief petty officer with 15 years of naval experience, nodded. "Almost always, and usually where different thickness plates meet." "That's exactly what I've been saying," Johnson replied, excitement in his voice. The standard welding pattern creates stress points that can't handle the thermal cycling in cold waters. Winters leaned forward. You know something about this? For the next hour, Johnson explained his alternative welding technique and the resistance he'd faced in getting it adopted. Winters listened intently, asking technical questions that revealed his own substantial knowledge of ship construction. I started as a ship's welder myself, Winters explained. Still do most of the repair work on board, and what you're describing makes perfect sense. The problem is, nobody who matters will listen, Johnson said. Maybe they would if it came from someone in the Navy rather than a shipyard worker, Winters suggested, especially if that someone had seen the consequences firsthand. You do that? Son, if your technique can keep ships from breaking apart in the middle of the ocean, I'd be criminally negligent not to try. Draw me detailed diagrams, write down everything. I'll take it to my superiors when I get back to Norfolk. Johnson spent that night creating comprehensive documentation of his welding innovation. He detailed the physics behind the technique, drew precise diagrams, and explained the advantages in terms of both strength and efficiency. Winters left the next morning with the package, promising to advocate for its adoption. Weeks passed with no news. Johnson continued his work at the shipyard, where the pace had become even more frantic. Liberty ships were now being completed in an average of just 30 days, and the welders were under immense pressure to keep up. Then came troubling news. Another Liberty ship, the SS Thomas Hooker, had broken in two during a North Atlantic crossing. This time the failure had cost lives. 17 sailors lost when the ship split suddenly during a storm. The incident prompted the Maritime Commission to launch an investigation. For the first time, the welding techniques used in the Liberty ship program came under serious scrutiny. Engineers and metallurgists descended on the shipyards, examining procedures and interviewing workers. One afternoon, Johnson was called to the administrative offices, an unprecedented summons that caused murmurs throughout the yard. "What did you do?" Morris asked with a smirk. Johnson said nothing, wiping his hands on a rag before heading to the offices. Inside, he found Donovan waiting alongside two men in naval uniforms and a civilian in an expensive suit. "Johnson," Donovan said, "these gentlemen want to talk to you about your welding technique." The civilian stepped forward, extending his hand. "Ellis Johnson, I'm Dr. Constance from the Maritime Commission. This is Commander Phillips and Lieutenant Brennan from the Navy's Bureau of Ships." Johnson shook their hands, surprised by the formal reception. "Chief Petty Officer Winters brought your welding innovation to our attention," Commander Phillips said. "Given recent events, we're very interested in your insights." For the next 2 hours, Johnson explained his technique in detail, answering technical questions and elaborating on the physics behind his innovation. Dr. Constance, a metallurgist, seemed particularly impressed. "What you're describing, Sobby," he said, "is essentially a way to create controlled flexibility in the welded joint, allowing it to absorb the stresses from thermal expansion and contraction rather than fighting against them." "That's right," Johnson nodded. "Steel becomes brittle in extreme cold. These ships are crossing the North Atlantic in winter conditions. The standard welding pattern creates stress concentration points that can lead to catastrophic failure." "And you developed this technique yourself?" Lieutenant Brennan asked, a note of skepticism in his voice. "Yes, sir. Working on river barges in Georgia. They face similar issues with temperature differentials, though not as extreme." "Mr. Johnson," Commander Phillips said, "we'd like you to prepare a demonstration for a larger group from the Commission and Navy. This could be significant." "I'd be honored, sir." As Johnson left the meeting, Donovan clapped him on the shoulder. "Told you your idea had merit. Looks like someone's finally listening." The following week, Johnson performed his demonstration before a dozen officials from the Navy, Maritime Commission, and shipyard management. Using sample steel plates of varying thicknesses, he showed how his staggered interlocking welding pattern distributed stress and prevented the concentration points that led to fractures. The officials conducted immediate stress tests, subjecting the welded joints to extreme pressure and temperature differentials. Johnson's technique outperformed the standard method by a significant margin. Dr. Constance was enthusiastic. "This could be the solution we've been looking for. The fracture problem has been getting worse as production speeds increase and winter conditions intensify. Not everyone was convinced. Several shipyard managers raised concerns about implementation. "We have thousands of welders trained in the standard technique," one argued. "Retraining them all would cause unacceptable delays. Not to mention," added another, "most of them don't have the skill level to execute this more complex pattern." Johnson had anticipated this objection. "Sir, with respect, the pattern looks complex, but can actually be broken down into simple, repeatable steps. I believe I could develop a training program that would allow even novice welders to learn it quickly." Commander Phillips nodded. "I think that's worth exploring. Dr. Constance, what do you recommend?" "I recommend immediate implementation on a test basis," the metallurgist replied. "Select critical join points on the next 10 ships for Mr. Johnson's technique, while maintaining the standard approach elsewhere. Then we compare performance data." The recommendation was approved, and Johnson found himself in an unexpected new role, not just as a welder, but as an instructor and innovator. A special team was formed under his guidance to implement the new welding pattern at key stress points on selected Liberty ships. The transition wasn't smooth. Johnson faced resistance from many white welders who resented taking instruction from a black man, regardless of his expertise. Some refused outright or deliberately performed the technique incorrectly. Donovan addressed the issue head-on at a team meeting. "Listen up, I don't care if you like Johnson or not, I don't care what color he is. What matters is that ships are breaking apart and men are dying. If his technique can stop that, you'll learn it and you'll use it properly, or you'll find somewhere else to work." The bluntness of the message had an impact. While the resentment didn't disappear, the outright sabotage ceased. Gradually, as Johnson worked alongside different welders, many began to recognize his genuine skill and knowledge. Frank Morris, initially one of the most resistant, grudgingly approached Johnson after witnessing a particularly impressive demonstration. "Where'd you really learn to weld like that?" he asked. "No disrespect, but they don't teach that kind of technique in any school I know of." "My father taught me the basics," Johnson replied. "He maintained equipment at a textile mill, but the pattern, that came from watching how things break and figuring out ways to prevent it. 15 years of solving problems." Morris nodded slowly. "Well, I still think the standard method works fine for most applications, but I'll admit your technique makes sense for these critical joints." It wasn't friendship, but it was a step toward professional respect, something Johnson had rarely experienced from white colleagues. Meanwhile, the test ships equipped with Johnson's welding innovation were closely monitored as they made their Atlantic crossings. The initial results were promising. None showed the fracturing that had become increasingly common with the standard-built vessels. In March 1942, Johnson received unexpected news. He was being temporarily transferred to the Norfolk Naval Shipyard to expand the implementation of his technique and develop a formal training program. The position came with a significant promotion and pay increase. "This is unprecedented," Walter Dixon remarked when Johnson shared the news. "A colored man being sent to instruct at Norfolk. They must really believe in your welding pattern. Or they're really scared of more ships breaking apart," Johnson replied modestly. Before leaving Baltimore, Johnson paid a visit to Chief Petty Officer Winters, who was back in port briefly. "I wanted to thank you," Johnson said. "None of this would have happened if you hadn't taken my ideas seriously." Winters waved off the thanks. "I just passed along good information. You did the hard part, developing the technique and standing behind it despite the opposition." Still, not many white sailors would have listened to a black shipyard worker. Winters looked thoughtful. "When you're in the middle of the Atlantic and your ship starts cracking apart, you don't care about the color of the man who might have prevented it. You just wish someone had listened to him." Johnson nodded, understanding the pragmatism behind the Navy's interest in his innovation. It wasn't about racial progress. It was about preventing the loss of valuable ships and cargoes. Still, he recognized the opportunity it represented. At Norfolk, Johnson encountered a different environment. As a civilian specialist brought in by direct request of the Maritime Commission and Bureau of Ships, he occupied an unusual position, respected for his expertise but still subject to the segregation policies of the base. His first day, he was given an office in the engineering building, but directed to use the colored facilities across the yard. His meals were to be taken separately from the white instructors and officers. The contradictions of his situation were stark, important enough to teach crucial techniques, but not equal enough to eat at the same table. Johnson focused on the task at hand. He developed a comprehensive training program, breaking down his complex welding pattern into teachable steps. He created manuals, instructional aids, and a certification process for welders who mastered the technique. The program began with a select group of experienced Navy welders who would become instructors themselves. Johnson's first class included 12 white men, most of them initially skeptical about learning from a black instructor. "Gentlemen," Johnson began on the first day, "I'm not here to change how you think about me or people who look like me. I'm here because ships are breaking apart and lives are being lost. My job is to teach you a welding technique that can help prevent that. Your job is to learn it, master it, and then teach it to others. That's all." The directness of his approach, combined with his obvious expertise, gradually won over most of the class. As they worked through the training, attempting to replicate his precise technique, their respect for his skill grew. By the end of the 2-week session, even the most resistant had acknowledged his mastery of the craft. One trainee, a senior welder named Howard Thatcher, approached Johnson after the final certification test. "I've been welding for 22 years, Thatcher said, "and I never would have thought of this pattern. It's brilliant in its simplicity." "Thank you," Johnson replied, "but the real test will be how it performs at sea." "About that," Thatcher hesitated. "There's talk of sending demonstration teams out on actual crossings to show shipboard welders how to apply the technique for emergency repairs. They're considering you for one of those teams." Johnson was surprised. "Me? On a Navy vessel?" "Nothing's decided yet, but your technique is generating serious interest at high levels." The rumors proved accurate. A week later, Johnson was called to a meeting with Commander Phillips and several other naval officers. "Mr. Johnson," Phillips began, "your training program has been remarkably successful. The welders you've certified are already implementing your technique at shipyards across the country. I'm glad to hear that, sir. Now we face a new challenge. Ships already in service need to be retrofitted with your welding pattern at their critical stress points. This means training shipboard welders who can't be brought back to shore." Johnson nodded, seeing where this was heading. "We're forming special instruction teams to deploy on Atlantic convoy runs," Phillips continued. "These teams will train welders and oversee retrofitting while the ships are underway. Given that this is your innovation, we believe you should lead one of these teams. You want to send me to sea, sir?" "Yes, as a civilian specialist attached to a Navy repair unit. Your focus would be strictly technical, teaching and implementing your welding technique." Johnson considered the proposition. It was an unprecedented opportunity, but also fraught with complications. A black civilian on a Navy vessel would face unique challenges. "I'd be honored, sir, but I should note that my presence might create difficulties." Commander Phillips looked uncomfortable. "Mr. Johnson, I'll be direct. The Navy operates under certain policies regarding race. These won't change simply because of your expertise. However, given the critical nature of this problem, accommodations will be made to ensure you can perform your duties effectively." "I understand, sir. I'm willing to accept those conditions if it means preventing more ships from failing." "Excellent. You'll deploy with the next convoy, departing in 10 days. Lieutenant Brennan will provide the details." For the next week, Johnson prepared intensively for his maritime assignment. He studied the specific construction details of Liberty ships already in service, identifying the most vulnerable stress points that would need priority attention. He assembled specialized tools and materials suited for shipboard welding repairs, and he mentally prepared himself for the unique challenges of being possibly the only black civilian specialist on a Navy vessel during wartime. On April 17, 1942, Johnson reported to the Norfolk Naval Base, carrying a small duffel of personal belongings and a large case of technical equipment. He was directed to Pier 7, where the Liberty ship USS Cadence was preparing for departure. As he approached the gangway, a Navy shore patrolman stopped him. "Restricted area, no unauthorized personnel." Johnson produced his identification and orders. Ellis Johnson, civilian specialist. I'm assigned to this vessel. The patrolman examined the papers skeptically, then called over an ensign. After a brief consultation, Johnson was allowed to board, where he was met by Lieutenant Brennan. Johnson, good. We're departing in 3 hours. I'll show you to your quarters and the work area. Johnson's quarters turned out to be a small storage room, hastily converted with the addition of a cot and footlocker. It was isolated from the crew's berthing areas, segregated, but also private, which was perhaps preferable given the circumstances. The work area was more impressive. A section of the cargo hold had been set up as a welding station, with all the equipment he'd requested and ample space for instruction. "You'll be working with Chief Petty Officer Winters and our ship's welding team," Brennan explained. "Winters specifically requested to be part of this program." "I'm glad to hear that," Johnson replied, relieved to know at least one friendly face would be aboard. When Winters appeared an hour later, his greeting was warm but professional, mindful of the naval hierarchy and watching junior officers. "Good to have you aboard, Mr. Johnson. My team is eager to learn your technique." The team, it turned out, consisted of 6 welders of varying experience levels, all white, all initially wary of their black instructor. Johnson had become accustomed to this reaction and proceeded as he had at Norfolk, focusing entirely on the technical aspects of his welding pattern and its importance to ship safety. As the USS Cadence departed Norfolk as part of a 20-ship convoy bound for Liverpool, Johnson began his instruction program. The first day was classroom-style teaching, explaining the physics behind metal fatigue in cold conditions and how the standard welding techniques created vulnerable stress points. "The problem," he explained, "is that these ships were designed and built for speed of construction, not durability in North Atlantic conditions. The continuous welding pattern works fine in moderate temperatures, but in extreme cold, the metal becomes brittle. When different thickness plates are joined with a straight-line weld, the thermal expansion and contraction rates differ, creating enormous stress at specific points." He drew diagrams showing how fractures typically began at these stress concentration points, then propagated rapidly across the hull once initiated. "My staggered pattern," he continued, "distributes that stress across a wider area. It allows for slight flexing without compromising the overall strength of the join. Think of it like a zipper versus a solid seam. The zipper can adjust to movement while maintaining its connection." The analogy seemed to resonate with the welders, who began asking more technical questions about implementation. By the end of the first day, the initial skepticism had begun to fade in the face of Johnson's obvious expertise. The real test came the following day, when they moved to practical application. Johnson had identified several critical stress points in the Cadence's hull that needed immediate attention. Under his guidance, the team would apply the new welding pattern to reinforce these vulnerable areas. The first location was deep in the forward hold, where the ship's bow structure joined the main hull, a junction of differing plate thicknesses that had proven particularly vulnerable in other Liberty ships. As the welders prepared the area, scraping away paint and cleaning the existing welds, Johnson noticed fine hairline cracks already forming along the seam. "See these?" he pointed out to Chief Winters. "This is exactly how it starts. Another few weeks in heavy seas, and these would propagate across the entire joint." Winters examined the cracks, concern evident on his face. "And we have over 20 similar stress points throughout the ship?" "At least. And every other Liberty ship in this convoy likely has the same issues." "Then we'd better get to work." Johnson demonstrated his technique on this first critical joint, working methodically as the welders observed. The conditions were challenging: limited space, poor lighting, and the constant movement of the ship as it plowed through the increasingly rough North Atlantic. Despite these difficulties, Johnson's hands remained steady, laying down the complex pattern of overlapping staggered welds with precision. When he finished, even the most skeptical welder had to acknowledge the result, a join that appeared far more robust than the original. "Now your turn," Johnson said, stepping back. "Each of you will apply this technique to a section under my supervision." Over the next several days, as the convoy pushed eastward into increasingly hostile waters, Johnson's team worked tirelessly, reinforcing critical stress points throughout the ship. The weather deteriorated, with massive swells and freezing spray creating hazardous conditions both on deck and below. On the 5th day at sea, Johnson was awakened before dawn by an urgent knock. It was one of the junior welders. "Mr. Johnson, sir. Chief Winters needs you immediately. We've found a major fracture in the aft hold." Johnson dressed quickly and followed the welder through the darkened ship. In the aft hold, Winters was examining a crack that ran nearly 3 feet along a welded seam. "Developed overnight," Winters explained grimly. "Sea's gotten rougher, and the temperatures dropped to near freezing, classic conditions for these failures." Johnson inspected the fracture. "This is serious if it continues to propagate." "The entire aft section could separate," Winters finished. "I've already informed the captain." As if on cue, the ship's captain, Commander Nelson, descended into the hold, accompanied by Lieutenant Brennan. Nelson was a veteran naval officer with 30 years of experience, known for his no-nonsense approach. "How bad is it?" he demanded. Johnson straightened up. "Bad, sir. This fracture is following a pattern we've seen in ships that ultimately failed catastrophically. It needs immediate attention." "Can you fix it?" "Yes, sir. But it's not just a matter of welding over the crack. We need to apply the reinforcement pattern along the entire seam, and possibly adjacent areas as well." "How long?" Johnson calculated quickly. "With all hands working in shifts, 12 hours minimum." Nelson frowned. "We're entering U-boat territory. I don't like the idea of reducing speed for that long." "Sir," Johnson said respectfully but firmly, "reducing speed for 12 hours is preferable to breaking in half in heavy seas." The captain studied Johnson for a long moment, then nodded curtly. "You have 8 hours, Mr. Johnson. Do what you can in that time." He turned to Winters. "Chief, give him whatever support he needs." "Aye, sir." As the captain departed, Johnson turned to Winters and the gathered welders. "We need to prioritize. This main fracture first, then the adjacent stress points most likely to fail next." "We'll work in shifts," Winters decided. 2 hours on, 1 hour off. "Johnson, you supervise all shifts. Your eyes are the ones I trust on this." For the next 8 hours, Johnson pushed himself and the welding team to their limits. The work was physically demanding and technically precise, made more difficult by the continued rolling of the ship. The temperature in the hold dropped to near freezing as sea spray leaked through ventilation ducts, coating surfaces in a thin layer of ice. Despite these challenges, the team made remarkable progress. The main fracture was fully repaired using Johnson's technique, and they managed to reinforce 7 additional critical stress points before the deadline expired. As Johnson inspected the final repair, exhaustion evident in his movements, Winters approached with a steaming mug of coffee. "Drink this. Captain's compliments." Johnson accepted gratefully. "The captain sent coffee?" "And says you're to get some rest. He's impressed with what you've accomplished." Winters looked around at the reinforced hull sections. "We all are. Will it hold?" "Thanks to your technique, I believe it will." Winters hesitated, then added, "Words come in that another ship in our convoy isn't so fortunate. The SS Harrisburg is reporting major hull fractures. They've requested emergency assistance." Johnson straightened, fatigue forgotten. "How bad?" "Bad enough that they've considered abandoning ship, but in these waters with U-boats hunting." "They need to try repairs first," Johnson finished. "Do they have welders aboard familiar with my technique?" "No, they're requesting someone from Cadence transfer over to assist." Johnson understood the implication immediately. "When?" "Weather's too rough for transfer now. If conditions improve by morning, a boat will attempt to cross." Johnson nodded. "I'll be ready." The weather did not improve. By morning, the convoy was fighting through 30-foot swells under leaden skies, with freezing rain lashing the decks. Despite these conditions, the USS Cadence launched a whaleboat to transfer Johnson and 2 Navy welders to the stricken SS Harrisburg, visible through the gloom half a mile away. The journey between ships was harrowing. The small boat rose and fell sickeningly in the massive swells, taking on water faster than it could be bailed out. Halfway across, a particularly large wave nearly capsized them, soaking everyone aboard with near-freezing seawater. By the time they reached the Harrisburg, Johnson was shivering uncontrollably, his clothes frozen to his skin. The transfer from the pitching whaleboat to the cargo ship's accommodation ladder was even more dangerous, requiring a perfectly timed jump as the boat rose on a swell. Once aboard, Johnson was rushed below decks to the primary fracture site. What he saw alarmed him deeply. A massive crack ran diagonally across the hull, nearly 6 feet in length and widening visibly as the ship flexed in the heavy seas. The Harrisburg's chief engineer, a civilian named Hargrove, greeted Johnson with obvious relief. "Thank God you're here. This thing's getting worse by the hour." "How long has it been developing?" Johnson asked, examining the fracture. "First noticed 2 days ago as a small crack. It's grown exponentially since then." Johnson traced the fracture pattern with experienced eyes. "It's following the weld line exactly as I predicted. The thermal stresses combined with hull flexing in these heavy seas." "Can you fix it?" Hargrove asked bluntly. Johnson didn't sugarcoat his assessment. "Not permanently, not in these conditions. But I believe we can reinforce it enough to reach port. That's all we need." For the next 14 hours, Johnson led the desperate repair effort. The conditions were far worse than on the Cadence. The Harrisburg's fracture was actively worsening, with ominous groaning sounds emanating from the stressed steel. The ship had reduced speed to minimize flexing, which put it at risk of falling behind the convoy, a potentially deadly situation in U-boat-infested waters. Johnson applied his staggered welding pattern in a modified form suited for emergency repairs rather than prevention. The technique involved creating a series of overlapping, interlocking reinforcement patches that would distribute the stress across a wider area while allowing for the inevitable movement of the hull. As they worked, the ship's radio operator brought increasingly concerning news. U-boat wolfpacks had been detected converging on the convoy's position. The reduced speed of the Harrisburg had not gone unnoticed by the enemy. "How much longer?" Hargrove demanded, the stress evident in his voice. 3 hours minimum," Johnson replied without looking up from his work. "Can't rush this, or it'll fail as soon as we hit the next big swell." Hargrove nodded grimly. "I'll inform the captain." The repair team worked with renewed urgency, knowing that both structural failure and enemy attack were imminent possibilities. Johnson pushed through his exhaustion, guiding the welders through each critical step of his technique. As they completed the final reinforcement section, the general quarters alarm sounded throughout the ship. The convoy was under attack. "That's it," Johnson declared, inspecting the completed repairs. "It's not pretty, but it should hold as long as we don't take direct torpedo hits nearby." Hargrove examined the reinforced hull section with obvious relief. "Remarkable work. I've never seen welding done this way." "Let's hope it's enough." Above decks, the situation was chaotic. The convoy had scattered under U-boat attack, with destroyers racing to drop depth charges while merchant vessels took evasive action. The Harrisburg, still unable to achieve full speed due to the hull damage, was particularly vulnerable. As Johnson emerged onto the weather deck, the ship's captain approached him. "Your repairs have given us a fighting chance, Mr. Johnson. Thank you." "They'll hold better if we can avoid sharp maneuvering, sir. That may not be possible much longer. We've had U-boat sightings on both quarters." Before Johnson could respond, a shout went up from the port lookout. Through the gloom, the distinctive wake of a torpedo could be seen heading directly for the Harrisburg. "Hard starboard," the captain bellowed. The helmsman spun the wheel, and the ship heeled sharply as it turned away from the approaching torpedo. Johnson grabbed a railing to keep from being thrown off his feet, his thoughts immediately on the stressed hull below. The Harrisburg's desperate maneuver succeeded. The torpedo passed harmlessly along their port side. But the sudden stress on the already damaged hull was telling. A deep, ominous groan echoed through the ship, followed by the sound of tearing metal. "Damage report!" the captain shouted into a speaking tube. Johnson didn't wait for the official assessment. He rushed back below decks, making his way to the repair site. What he found was both concerning and validating. The original fracture had indeed started to tear again under the extreme stress of the evasive maneuver, but his reinforcement pattern had prevented catastrophic failure. Instead of propagating straight across the hull as it would have with traditional welding, the crack had zigzagged along the edge of his pattern, dissipating energy as it went. Hargrove arrived moments later, his expression shifting from fear to amazement as he assessed the damage. "It held," he said incredulously. "That maneuver would have torn us apart otherwise." "It's still serious," Johnson cautioned. "We need to add additional reinforcement immediately." For the next several hours, as the convoy continued its desperate run through U-boat-infested waters, Johnson and the Welding team worked to further strengthen the damaged section. 3 more torpedo alerts came, but each time, the Harrisburg's modified evasive actions, gentler turns suggested by Johnson to minimize hull stress, proved sufficient. By dawn, they had cleared the most dangerous waters, and Johnson's reinforced hull section had held despite the extreme conditions. The Harrisburg would make it to Liverpool, carrying its vital cargo of tanks, ammunition, and medical supplies for the Allied war effort. When they finally docked 3 days later, naval engineering officers and maritime commission officials were waiting to inspect Johnson's emergency repairs. What they found exceeded all expectations. Not only had the repairs held through continued rough seas, but the staggered welding pattern had prevented the propagation of new fractures that had begun to form in adjacent areas. Dr. Constance, who had flown to England specifically to examine the results, was ecstatic. "This is even more impressive in an emergency repair context than in new construction. The way your pattern arrested crack propagation along multiple vectors, it's revolutionary." Word of Johnson's successful emergency repairs spread rapidly through the Allied shipping authorities. Within weeks, his welding technique was being implemented not just on American Liberty ships, but on British and Canadian vessels as well. Training programs based on Johnson's methods were established at major ports on both sides of the Atlantic. The impact was immediate and significant. Hull failure rates among vessels implementing the new welding pattern dropped by over 80% by the summer of 1942, saving countless ships, cargoes, and lives. The technique became known informally among welders as the Johnson pattern, a rare attribution to a black innovator during that era. For Johnson himself, the recognition brought unprecedented opportunities. Upon his return to the United States, he was offered a permanent position with the Maritime Commission as a senior technical advisor, the first black American to hold such a role. He established a comprehensive training program that eventually certified over 3,000 welders in his technique, many of them women and minorities entering the industrial workforce for the first time. The technical aspects of Johnson's innovation were formally documented in a paper published by the American Welding Society in late 1942, titled "Thermal Stress Distribution in Dissimilar Thickness Welded Joints," with Ellis Johnson listed as the primary author. The paper was revolutionary, not just for its technical content, but for the recognition it represented for a black inventor in a field dominated by white engineers. Chief Petty Officer Marcus Winters, whose initial advocacy had brought Johnson's technique to the attention of authorities, received a commendation for his role in the innovation's adoption. The two men maintained a lifelong friendship, with Winters later commenting that Johnson didn't just save ships, he saved thousands of sailors who never even knew his name. Frank Morris, the initially skeptical welder from Bethlehem Fairfield shipyard, became one of the most vocal proponents of Johnson's technique, eventually becoming a lead instructor in the Maritime Commission's welding program. When asked years later about his changed perspective, Morris simply said, "Johnson made me a better welder, and that made me a better man." The Liberty ships, reinforced with Johnson's welding pattern, continued to serve well beyond their intended lifespan. Originally designed as essentially disposable vessels, with an expected service life of just 5 years, many remained in operation for decades. Several were still in commercial service in the 1970s, a testament to the durability provided by Johnson's innovation. In the decades following the war, the Johnson pattern evolved into a standard technique taught in welding schools worldwide, though often without attribution to its originator. The staggered welding approach proved valuable, not just in shipbuilding, but in numerous industries where joining dissimilar metals or managing thermal stress was critical, from aerospace to automobile manufacturing. Ellis Johnson himself continued to innovate in the field of metallurgical engineering, earning several patents and establishing a small but successful consulting firm that specialized in solving complex welding challenges for industrial clients. He never sought the spotlight for his wartime contribution, preferring to focus on the technical aspects of his work rather than its historical significance. It wasn't until the 1990s, nearly 50 years after his innovation helped turn the tide in the Battle of the Atlantic, that Johnson's contribution was formally recognized by the American Society of Naval Engineers. At a ceremony in Washington, D.C., the then 82-year-old Johnson was awarded the Society's highest honor for his revolutionary welding technique that saved countless ships and lives during World War II. In his brief acceptance speech, Johnson remarked simply, "I never set out to make history. I just saw a problem that needed solving, and I knew I had the solution, even when no one wanted to hear it from someone who looked like me." Sometimes the right answer comes from unexpected places, and the wise listener is one who cares more about the truth than its source. Today, modern naval vessels still incorporate elements of Johnson's stress distribution principles in their construction, though advanced computer modeling and new materials have led to further refinements of his original technique. The Liberty ships themselves have almost entirely disappeared, scrapped or lost to time. But the handful that remain as museum ships still bear the distinctive welding pattern that Ellis Johnson developed. The story of how one overlooked black welder revolutionized shipbuilding during humanity's darkest hour serves as a reminder that innovation often comes from those we least expect, and that in times of greatest need, talent and truth must transcend prejudice. Johnson's legacy lives on not just in welding textbooks and engineering principles, but in the thousands of lives saved by ships that didn't break apart in stormy seas, carrying their vital cargoes safely to shore. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.